In this video, I want to do some examples where we convert English sentences into logical statements. So in our last video, we looked at De Morgan's laws for quantifiers, so how we can negate quantifiers. And we did one example where we converted, where we looked at the negation of a statement and how we express it in symbols. In this video, I want to do more examples where we convert sentences into logical statements. So let's look at our first example, which says there is a professor at SCU with a PhD and an MD. So when I see the words there is, that reminds me of my there exists. And the X here, well, it's talking about a professor at SCU. So it makes me think that X is, having to do with that. And then, the action here, the bulk of the statement is, well, this person has a PhD and they have an MD. Well, I see a connecting word there. The word and makes me think of my and operator. And then there's kind of two parts. They have a PhD. They also have an MD. So I'm probably going to need statements to represent each of those. Okay, so let's start to write this. So I'm going to let some statement for having a PhD. Maybe I'll call that P of X. So P of X is going to be X has a PhD. And I need a separate propositional function for having an MD. Maybe I'll call that MX. I'm going to let MX be X has an MD. Okay. I have these propositional functions. I need to specify what the variable is, what the domain of this variable is. Okay. So I'm going to say the domain of X. What are we talking about here? Well, we're talking about professors at SCU. Domain of X is SCU professors. SCU professors. Okay, so I'm ready to now express this using my logical symbols. So there is part I can write as there exists. There is a professor at SCU, so there exists X with a PhD and an MD. So I need to have my P of X and my MX. So there exists an X such that X has a PhD and X has an MD. Okay, and then the way I can indicate that there exists applies to this whole and statement is by putting a parentheses around that whole thing. And that parentheses is important because without the parentheses, order of operations says, well, the there exists would take precedence. I would be doing this first. But that's not what this means. The exists applies to this whole thing. And we got it. Okay, let's take a look at another example. Part B says, now there is exactly one professor at SCU with a PhD and an MD. Well, the setup of this is virtually the same as the previous one, except now it says there is exactly one. So let's start by saying I'm going to be using the setup of A. So I'm going to be using all the definitions that I had in A for P of X, for MX, for the domain here. But the fact that this problem says that there is exactly one makes me think of my there's a unique. This time I'm going to use the there is a unique thing. Okay, so the only difference is this is going to have a there is a unique X such that P of X, so X has a PhD, and M of X, X has an MD, and that is the only difference. Okay, eventually we'll look at some examples where we try to express there is exactly one without using the uniquely exists, just using the other operators that we have, and that's a bit more of a challenging task. But for right now, this is just fine for us. Okay, let's do another problem. Part C says no one has seen an alien. So no one has seen an alien. Okay, well, what quantifier goes with no one? One of the things I observe about this, about the phrase no one is, well, this is the opposite of at least one. This is the opposite, or the negation of at least one person has seen an alien. So if I can express at least one person has seen an alien, then I'm just going to try to negate that. Okay, so let's start introducing some propositional functions. I need something to represent having seen an alien. So I'm going to maybe I'll call that a of x for alien. So a of x is going to be x has seen an alien. X has seen an alien. And then I need to specify my domain. The domain of x. The domain of x. For this one, it can't be SCU professors anymore because it doesn't mention anything about professors. It talks about no one. It talks about people. So the domain of x is people. All people. Okay, so I got my domain. So if I were to try to first write, at least one person has seen an alien, that would be, let me put this under, let me just keep it in black. That would be there exists an x such that a of x. There exists x such that a of x means at least one x, at least one person such that a of x. So at least one person has seen an alien. At least one person has seen an alien. That would be there exists an x such that a of x. But I want the opposite of that, because the opposite of at least one person has seen an alien would be no one has seen an alien. So I need to negate this. So I need to negate my there exists x such that a of x. That now means what we want it to be. This would mean no one. This would mean no one has seen an alien. Okay, and that is what we're looking for. That is what we're looking for. Another equivalent way to see this, to write this, would be to use De Morgan's law. So this is equivalent to bringing the negation inside the quantifier. And I'd get not a of x. But when I do that, the exists changes to a for all x. So this would be saying for all x, for all people out there, it's not the case that that person has seen an alien. That's the same thing as saying no one has seen an alien. Okay, so that would be another equivalent way to write the answer. Okay, so I want to end this video with one last example. And I want to give you an opportunity to try this first. So this one says that the campus is quiet when every SCU student is home. So I want to have you try this first. So give the video a pause for about 3 minutes to try this. Pause it in 4, 3, 2, 1. Pause it and try this on your own. This time when you practice problems, that is actually the most valuable time. So definitely take advantage of this time, but really try this on your own. It's a great way to see, how well are you understanding this stuff. All right, so hopefully you did that. Hopefully you paused it and tried this on your own. Let's talk about it now. Okay, so one of the key connecting words that I see here is the word when. And the word when is just a synonym for the word if. Okay, so I can reword this in my if then format. So this would be saying if or when every SCU student is home. So if every SCU student is home, okay, left myself just the right amount of space, then the campus is quiet. Then campus is quiet. Okay, so my sentence is the same thing as sort of expressing it in this if-then format. And now it's clear to see that, okay, I'm going to have some sort of implication in my final answer. Okay, so let's break this down a little bit further. What are other keywords that I see here? I see something about every. So every makes me think of my for all. For all. So there's got to be for all x. And what is x referring to? Well, it's every SCU student. So x seems to be referring to SCU students here. And then the other key parts of this is, well, there's something about, the student being home, and there's something about campus being quiet. Okay, so I'm going to need some letters to refer to those various parts of this. Okay, so first let's deal with this home part. So it's talking about these SCU students being home. And that's where I'm going to need my propositional function. I'm going to call this H for home. And H of X is going to represent this home part for me. So I'm going to let H of X be the propositional function X is home, where the domain of X, the people that we're talking about here, are SCU students. So SCU students. Domain of X is SCU students. Okay. There's also this other part, the then part, which talks about campus being quiet. Well, there's no quantifiers there at all, so that's just a straight up proposition. So let's have a letter to represent this. Maybe I'll call it Q for quiet, or maybe I could call it C for campus. So I'm going to let Q be the proposition campus is quiet. Campus is quiet. Okay, so I'm ready to express this with logical symbols now. So the key thing that I see here at the core is this if-then statement. So I'm going to have some implication. So I'll have some implication. I know what comes at the end is campus is quiet. And I know that that is Q. So that's going to be Q. And the if part of this says every SCU student is home. So that would be saying for all X, for all SCU students X is home. Or another way to write that is H of X. And let me just move this a bit closer. So for all X, H of X, that implies Q. And there we have it. There we have it in logic. One quick thing to remark about this is, remember that in our order of operations, when I have a for all statement and a if then implication, order of operations says the quantifier happens first. So we are doing the for all H of X part first, and then after that, we are doing this conditional to Q. And if this looks familiar, that's good, because we did a very similar example in a previous video where we talked about the difference between this versus if there was a parentheses here in terms of what they mean.